Let's talk about research literature, and I hope I didn't lose anybody already, because oftentimes it's like, I don't want to talk about that. I remember taking research methods in grad school for the first time and thinking, this is the silliest. I don't want to do this. I want to learn about muscle physiology. But I had the wrong mindset about what it means to be educated and understand how to interpret data. If you can't interpret data correctly, that's when we get sent into these wild goose chases that we see in exercise and sports science, nutrition sciences all the time. Many times people pull a research study, one study, read it, apply it, and that's gospel. The problem is that that's one study, and one study does not a theory make. So we have to be very careful in many respects of how we handle the research literature. If you're going to read research literature and interpret it yourself, there are some things that you should do in order to make sure that you're not going off into the weeds and setting yourself up for some disappointment when it comes to the results that you expect if you're a trainer or a coach or for yourself. So I'm making a video series on key issues to look at with research literature. And the first one I'm going to talk about, and I'm going to make these very short, so I don't want to drag us out because I already know for many this may not seem like an interesting topic, but I hope that you'll invest in this idea and these ideas I'm talking about, and make sure that you're not making these fundamental errors, or you're just, when you read the studies, you're reading them with a critical eye. Always be a skeptic when you come to research literature. The peer-reviewed process is not perfect. It doesn't mean everything is perfect. There's been people that have put research out there, has been published, that has been poorly done or just completely fabricated. And so that's why we have to take the whole body of the literature and look at it in its totality in order to make decisions about how to drive best practice. So here is the first thing that I would put out there. And I could start with a lot of things. I just select this one because I just read a study just a minute ago. And this is what kind of got me thinking about these topics. Control groups. Control groups. When you read a study, in order to really infer that the experimental condition is better than nothing or better than whatever the control was, you have to have a control group. And I say nothing there, and therein is the problem. Many control groups are sedentary controls or untrained people. Okay? Now, if you're training sedentary people or untrained people, you could argue that, okay, that's better than doing sedentary or untrained. But if you're trying to say something is superior training method to what's being done currently, like in athletes, you can't compare it to untrained people. You need to have athlete controls and athlete that are being trained. Otherwise, you're comparing apples to oranges. One of the problems in health literature is people, a lot of times we use sedentary controls. Why are they the control? The control should be healthy people. And so if you're saying, okay, this particular exercise routine is better for lowering LDL cholesterol, I'm just making up something here. Use healthy people as the standard, because if you're using sedentary people, that's like, again, having a training study with untrained people. Everything's going to work in untrained people. I mean, I can't imagine too many things that will not work if it's an organized training plan that will not work with untrained people. So it's hard to say that whatever's being studied, whatever these authors have come up with, is the way to do things. The study that I just read, I'll give you an example from actual literature, was on carbohydrate restriction. So they took these individuals that had a regular diet with, I think, about 43 grams of sugar intake per day, and then the other group had about 23 grams of sugar. So they reduced the carbohydrates. They also reduced the calories by about 400 calories. And so you have a group that has higher calories and higher carbohydrates. They reduce the carbohydrates and they say, oh, it's the carbohydrates that made the impact. That is not correct. If you have a control group where you just lowered the calories in the experimental group, and it just happened to be that you lowered it through carbohydrates, it's hard to say it was the carbohydrates' fault that, these individuals that were at 400 calories more were seeing negative health benefits. Okay, or we're not seeing as good of, not getting the health benefits of the carbohydrate group that cut. All right, and so therein you have a control group that it wasn't apples to apples, it was apples to oranges. You just reduced calories through carbs, and you said, well, it's got to be what if it's the calories? It probably, in fact, there's another study that would contradict that the authors rightly pointed out that said when they cut calories and replaced those calories with fat, nothing happened. So it might have just been about the calories. So the use of a control group there could have been done better in order to support, and maybe it could be that the carbs are the problem. I'm not trying to defend carbs. They don't need defense. They're an inert object. But what I am saying is we need to be careful when we look at control groups. I've seen this done over and over again. When these lofty generalizations then are made, I've made that mistake, okay, and not looking at what the control group was. So when you're reading research literature, be critical. You can't just read the abstract and apply all that information. If the study interests you and it's something that you find might be valuable in the way you're coaching, you're training people, or your own training, you have to read the study carefully, and that is one place I'd start. In the next video, I'm going to talk about the individuals of the study a little bit more closely. So this is about control group, though. Does it have a control group? If it doesn't, then it's just kind of interesting information, but you don't know. Like in studies of kids, growth is going to produce gains in strength, just having them age, maturation. So you have to have a control group that's matched by age and the same activities that they're doing as the experimental group in order to make strong conclusions about this method being superior to nothing. And if you are going to compare it to another training method, then that training method has to be implemented in the control group. So the control group doesn't have to be this group that's just laying on the couch. In fact, in many cases, it shouldn't be. And that's what I'm basically the point I'm trying to get across. So if you're going to interpret literature, you're going to try to apply it, you have to have a control group, and you need to be critical of what that control group is. Is it really at the baseline that is acceptable in order to make inferences about the experimental group? If it's not, then I would exercise a lot of caution anyway, but I exercise a lot of caution with the results of that study. Hope you found this video helpful, not too preachy, but research literature's used many times as weapons, and sometimes we don't really understand it like we should. And I've made many mistakes interpreting research literature too, so I'm not above this. I'm just trying to point out some flaws that I see, and so you can avoid those mistakes. If you like this video, subscribe to my channel, like this video, and comment below if you are offended or think this is just the greatest thing ever. I'd love to hear from you, and I will see you in the next video.